Yes, hello everyone. CC++ is here. So today I have a special occasion for the stream because I'm finally ready to release the source code for the project called Google Maps 8-bit for NES. So if you don't know what is all about, please watch my first video on this channel, which briefly describes what is the project, why I building it, etc. But for those who know already, welcome to the stream. And so yeah, basically you can find every source code on my GitHub page, CC++. Just search it on GitHub, and also you can find a link inside description. And I also decided what today I will do some live compiling, so just to show how I do things, how you can prepare yourself your Raspberry Pi. And in order to do that, I decided it will be fun to do it in speedrun mode. So I hope you all know what is speedrun about. It's basically to do something like completing the game in fastest possible way. And I decided to call this speedrun country percent because the ultimate goal is to have any country label being shown on NES. There are a few steps listed here, so basically what I am planning to do is to start with Raspberry OS on SD card, like the new one without any modifications. When I install every source, well, I will check out the source code and will compile directly on Raspberry Pi. So there are a few components like SDL2 drivers, Ceph, etc. And the last two steps will be to install this Raspberry Pi with SD card to NES, booted, and show first logo, and the last the map itself with country label. So I did a dry run like yesterday, and it took me about 2 hours because there are so many different small things what I completely forgot about, and hopefully today I can do it faster and it will be speedrun. Yeah, so hello RMS. For me it's 10 p.m. So yeah, I'm based in Europe, and yeah, it's quite early at the morning here. Yeah, basically that's it for the today. Hopefully we can make it under 2 hours, but just in the sake of disclaimer, well, the last two steps of this speedrun will be highly dependent on the health of NES itself, and well, it is piece of technology which is like 30 years old, and anything can happen. So hopefully it will not explode on the stream, but yeah, we will see. Yeah, so as I said, link to the code itself you can find in the description. And yeah, we will start in a few seconds. Yeah, so here I have my SD card already loaded. And I will install it to my Raspberry Pi. This one is Raspberry Pi 3B. Then later I plan to use Raspberry Pi 3A, but this one just have radiators uh, here, so well, because the compiling it takes some CPU time, and we need to have a good cooling system, which I don't have on the another Raspberry Pi, which I actually use inside the NES. Okay, so let me check if everything is set it up, and we are basically ready to go. So yeah, as you can see, it is booting up the Raspberry Pi for the first time. And the first step is just to configure everything, like Wi-Fi, make sure that it will be booted in the console mode, and yeah, this is like first step. Okay, cool. So we have a Raspberry Pi wizard, and we just basically selecting the default configurations. So yeah, I need to introduce the password. So here I will just temporarily close my OBS cam. Yeah, so just connection to my Wi-Fi, and when it's done, we can just do one final configuration and it will be okay. Okay. Cool. So let's skip installing of software and we will restart later. The next step is just to run the in our configuration. It's sudo raspi config. Okay, so few things. First of all, let's select console auto login, and the second one is to enable SSH. So in the case of problem, we can just SSH inside and see what is going on. And I guess it should be okay. Cool. First step is done. Let me just change a little bit settings of font here so it's be better looking on the stream. So let's use Terminus Bold and the biggest one. Okay, I guess it should be better. Cool. So the next step is to do a checkout of the repository, the Pipu, and just build it. So if you're not aware of, this is the repository which contains the source code, modified source code from the NES Doom project, and I modified it in the way to obtain the possibility to have dynamical palette on the NES. So normally I will use Git, but here let's just obtain the snapshot, because otherwise we need to set up the SSH key, and this is just too tedious to do on stream. Cool. And I need to rename it because I have some special boot up scripts related to the path. Also, I need to install some dependent libraries. For this repository, it's libusb, and we need to install the development libraries. Well, includes and stuff. Yes. Okay, cool. So let's go to a directory and see what we have here. So it should work, just type in make here. Some warnings, but we don't care. Cool. So now if I run the executable, yes, and this is basically normal. So the last thing before go, we need to copy the OS configuration. So we have a config file here, and this one basically defines the different parameters on boot of the system, and I just need to copy it in the right place. Yeah, that's it. Okay, so the next part is to check out the SDL sources and to compile and install it. This is one of the most time-consuming parts. Well, not really, not this one, but yeah, it will take some time to build it. Okay, so let me get again the snapshot. This time it's libsdl/org. The name of the repository is SDL, and we need to check out specific tag. So in this case it's release dash 209. Okay. Let's unzip it. Cool. And before we go building it, we need to install some build dependencies. So first of all, let's modify the default sources list of apt. Oh, fuck. I need to run it in sudo mode. Okay, cool. Now I can do sudo apt update. Okay, and now I can install build dependencies of SDL. Yeah. For those who are not familiar, SDL is a simple direct media layer, and basically it is kind of dependency for game development. Like it provides the low-level functions to work with graphics, music, joysticks, etc. And here we need to install it and build from the source, because this is a way of inject the game or browser data in the format compatible with PyPPU squared, which will translate the data to the NES itself. Yeah, most of the time on this stream we will be just sitting um, and see how the compilation goes. Well, in this case, this is just installing the dependencies in order to build the SDL. Yep, we are good with dependency. So now let's go and build it. Okay, so it's basically running configure, make, and make install. So should be pretty straightforward. Yeah. So the first part is in configuration of in compilation of SDL is configuration. So basically the configure is the program which checks every dependencies necessary in order to build the project. So it's checking for some PIF trading libraries and video drivers and audio drivers and stuff. And we can now run our make. So I plan to run it like in this free parallel process, because, well, the rule of thumb is to run with like number of cores plus one. So here I have Raspberry Pi with 4 cores, but if I run it in 5 parallel mode, I afraid it will be overheated right away. Even if I have like the radiators here, they are already becoming too hot, so I have a passive cooling, and it's better to just limit the amount of CPU load. Yeah, so hopefully it will not take much more time. Yeah, you can already see here what there are some like as well the last files what need to be compiled. I hope it will be okay in few more minutes. So yeah, another possibility to compile the code is to do the cross compilation. Like here, I am compiling directly on Raspberry Pi itself, so at the same architecture and same processor on which the code will be running. But like the faster way is to do it on the powerful computer. Okay, so cool. We have it compiled. And the last one thing here is to also replace the standard libraries of SDL, because, well, it is important otherwise, yes, I forgot to run install. And I just also need to move it to the correct location, because by default it will not look at user local lib, but the standard libs which already have SDL. And sorry, and otherwise on the runtime it will load not the correct library, and we will not see anything on NES screen. Yeah, I believe this is the right command. So we have on the left our custom build library, and on the right the one which comes from this Raspberry Pi OS by default. Cool. So the next part is to compile Ceph. Ceph is a Chrome embedded framework, and actually I need to compile the custom version which use SDL. And this is one of the most time consuming one, because there are so many dependencies to get. And yeah, first of all, let's go again and grab sources. So this time it will be SDL 2-ceph archive refs heads and just the branch which I called ceph-nes. Cool. Okay, we unzip it and just rename. Yeah, it should be good. So few dependencies to install. I need to have this one, libsdl2-image-dev. Yes. Yes, and another important part is to load the C flags and LD flags of SDL. And it's located oh fuck. Well, actually I did not do SDL part correctly. Let me see. So let me undo the split. Yeah, basically I forgot to copy the modified version of SDL driver. So cd appmods ls cd sdl2, and the one what I forgot to copy is actually the one which uses the dummy driver in order to sync the data to the NES. So this is pretty important. And let me just copy it into the right place. So cp, and I will copy every C file from here to daily release, when it should be SRC, when it should be video, it should be dummy, and it should be okay. And this way, if I do ls_lr, I see this is a new one, like from, well, 10 October, but whatever. Cool. Okay, make clean and make sheet3. Yeah, sorry, I need to redo this because I forgot to apply actual patch. Yes, unfortunately I need to compile the SDL like twice, but well. This sometimes happens, and on the live stream it's a little bit embarrassing, and also the fact that I am trying to do speed run. Well, actually, these warnings are a good one because it actually shows what we apply the correct version of the dummy driver. We don't saw them last time when we did compilation. Okay, so it's nearly finished. Hopefully this time this is a good one. So again, what I need to do is to install it. And the second thing is to copy to the right location. Cool. Oof. And now we are going to compile Ceph CDA. SDA. Okay. Do I have already sources? Yes, I do have. And I also need to install CMake, because this is kind of build system what is used for SDL2 Ceph. Okay, cool. Okay, blah blah blah. Let's just do a make build here. Cd to it, and we need to run now CMake with correct architecture, because by default it will try to compile x86-64, I guess, and this is not what we want for our Raspberry Pi. The correct architecture is ARM. Cool. And we are back again, waiting just to download some dependencies. In order to remind you, Ceph is Chrome embedded framework, and it is written in C and C++. The core part is based like the custom version of Chromium, so that's why you need also to fetch some dependencies which are which are basically the engine files. So those which run JavaScript and do some basic stuff. And off top of that, we have a framework itself, which provides some useful bindings. Well, the bottom line, what we just need to wait for it to be downloaded. Downloaded and extracted. And it will take about, I don't know, 10 or 15 minutes. So I think I can show something cool meanwhile. So I can show you meanwhile, while we have this part being extracted, the new tiles which I'm using. Because, well, you know, the original one uses the tiles really similar to Dragon Warrior or Dragon Quest, not Zelda, by the way. And this is just impossible to do a proper open source release because those are copyright protected. So I spent some amount of time searching for a good looking tile set, and finally I decided to do it myself. Well, not to do it from scratch, but modify the existing one, which I found on Open Game Art. Well, you can find all of this information on the GitHub page for this project. Like this part I called map NES. Yeah, because this is a map for NES. And, well, as always, you can scroll, pan, and if you scroll close enough, you can see country labels. Like, yeah, France, United Kingdom, Denmark, Poland, everything. And obviously we have some kind of issues here because, well, for example, let's go to observe Iceland, and Iceland like covered half in forest and half is in sand. But anyway, the algorithm is not perfect. Yeah. Also, now particularity of this algorithm is to show the most part of Africa covered with mountains, which is, well, not that true. Yeah, while it's still extracting the files for Ceph Core, let's just quickly show the source code page. So as I said, it's on GitHub. Anyone can access it. There is free repository currently. The mapness, this is a backend for 8-bit map for NES. So basically this part, which I just shown. Next is Pipu, so the modified version of the source code from NES Doom project. So basically this is a program which registers the button presses from joysticks and also feed NES cartridge with the correct information like the graphical one. And SDL2-Ceph, this is modified version of itself which use SDL2 in order to render web pages. In this case we render the map itself. Yep. Yes, it was a brief divergence from the topic itself. And while it's still extracting, maybe I can show you code around. So for the mapness itself, yeah, the code is here. It is the server is written in Python, and it uses Google Maps API in order to fetch tiles. By the way, the geospatial labels are from Natural Yoff, and it's written using the Mapnik library, the cartographic one. So yes, I do some explanation about tiles. Basically, the dependencies is Flask for the server, Pipu for image library, and Mapnik for the cartographic tiles. Yeah, you should have a Google API in order to run this project, and the running itself is done like in one command, and then you can have access to the local host with the map itself. Most of the code goes here to the app py file. Yeah, there is some bunch of some stuff. It's pretty obvious, but I explained the core concept in one of my previous video. What else can I show? Yes, so Pipu here, you can see what I have, like 22 comments ahead of the original repository, because this is basically what it gets to do the like the implementation of dynamic palettes. Yeah. So the most important modifications was done here to the frame processor. I don't think I have time. Okay. And we finally have some progress here. Yeah, but it will still look like took like I guess about 10 more minutes, so we can easily speak a little bit more about the source code here. I will not go throughout all of this code. Okay, it's finished. Cool. So now we have a configuration bunch CMake been done. Now we can actually make this project, and we need just to build how does it called, SDL-Ceph, I believe. Okay, cool. So it will took an hour, I don't know, 10 minutes. Let's go to this back again. So the code itself is low level C stuff, doing this palette modification of NES. I don't think it make much of a sense to speak about all of this right now, but just in order to give you a brief understanding of how does it work. The concept is to have a dynamic palettes. What does it mean? Like in the normal static way, you fix the palette colors and you use it like all along. So for example, for the NES Doom project, there are predetermined sets of colors, like 13 colors, something like this, and they don't change during the execution of the program. And this does work somehow, because there are some clever tricks like differing, but here it will not provide you with the correct aesthetics of the look if you just use one fixed palette. Like if you go to the one direction on the map, it will be look good, for example, when you have only like the forest. But then if you change to the sea area, or I don't know, some sandy place, the same palette what was used for the forest one will not look that great. Yes, because you have only limited set of colors, something like 13, and it's just not good looking. So the way to solve this problem is to use dynamic palettes. What does it mean? It does mean what, like, in each 1 or 2 seconds we recalculate the palettes which are most appropriate for this current view, well, for this current map view, or in general just kind of graphics what you want to show. So for example, if you show something like sea, that means what your palettes need to contain at least few variations of the blue color. And if you show want to show sand, you need to have yellow color. And basically there are a big pile of predetermined colors which we store in the map, and we basically one kind of each second calculate the statistics of color distribution of this particular frame, and based on this we construct the palette using the most common color. Yeah, this is a bit of a fuzzy explanation, but I think it becomes clear when you read the code and see my comments. By the way, don't hesitate to post any comments to this video or another one, and I try to answer and clarify some points. Okay, so we are nearly finishing the compilation of SDL Ceph. It's a good thing. Well, we have bunch of warnings, but it's 2021. Who cares about warnings, right? Okay, we have some kind of error. Can I reproduce it? Yes, I can. No rule to make target needed by. Okay, interesting. Okay, we enter the magnificent world of debugging. Okay, I guess I know what is the problem. Yes, here I do move instead of copy. So what I need to do, I need to copy back. And I need to copy back to the correct location. And if we now do make again, does it work? Okay. Is it correct? Okay, permission denied. Sudo. And so hopefully it will link. It will link and we will have the correct version. Cool. And we're back on track. So there are a few more things what I need to do before loading this SD card to another Raspberry Pi. First of all, I need to install XVFB, This is kind of X11 emulation, which I do need because otherwise Ceph SDL will complain. Next, I need to do some kind of I need to generate SSH key. So yes, I will not use passphrase. Okay. And yep. Just copy this to the correct location. Cool. Before we go, few more things to do. I need to create a folder for logs. And what else? What else I need? I need to create the boot configuration. So actually the file what I'm talking about is located in etc rc local. So this is the script what is normally gets executed once the Raspberry Pi get booted up, and I need to put here my commands in order to load Pu squared and SDL Ceph. Let's do it. So I guess it's here, cdos, yes. There are three lines. The first one, yeah, at the bottom. The first one is running the Pipu squared and drop some logs just in case of just in case of problem. The second one is creating the SSH tunnel between the Raspberry Pi itself and my server running in the local network. And the last part is actually running the SDL Ceph example. So here it does define the video driver dummy, so we can use our custom SDL tool which we just built. Next, xway fb run. This is just X11 emulator what I need to run for whatever reason. And there are also some parameters about not running in sandbox mode and disable GPU, because we do rendering here on CPU itself. Okay, so let's try to run it actually. No, first let's copy it. So here I will copy it to the location of etc rc local. Cool. Now if we do etc rc local, yes, okay, yeah, at least we can see here what is running, so this is a good sign. The bad sign that I lost my connection to the console, but it should not be a big problem. So the next part here is to actually run the same code, but on the actual Raspberry Pi, which I plan to use. So let me just grab it. Yep. So this is Raspberry Pi 3A Plus, which I do actually use inside NES. And now I will take the SD card from here and place it directly here. The one thing to do is just to verify what it can boot, and once we verified what it can boot, we will place it directly inside NES, and we will see if we can have logo on boot. So yes, this is just a verification that everything is working as expected. Cool, and if you're on top, we do have SDLSEF gets running. And I think this is a good sign. Okay, so now let's see if it does work in the NES itself. Okay, let me bring my NES. Okay, so this is a good sign. I just connected my AV to HDMI. So this is coming from NES. This is goes to my, well, to my stream and to my monitor. And the fact that it is blue, it is a good sign. So next, what we are doing? Let's install our Raspberry Pi. Yeah, the Raspberry Pi itself will receive the voltage from the NES, so that's why I need to do few connections. So here I'm getting the 5 volts and the ground. Okay, so few more connections. This one goes to AV output, and I don't have sound, so only the video signal. Oops. Okay, will it work from the first try? We will see. So if everything goes as expected, we should have a boot logo in, like, I don't know. Yeah, and we have it. Cool. So does it work for the countries? I need to grab my NES. Cool. I forgot to connect. Fuck. Fuck. Oh, fuck. Sorry. I have some other projects which I would like to share with you. So please like, subscribe, and let me know, did you like it, or what was your feeling about this